We have just seen the effect of urea on HSA denaturation, the change in absorbance upon adding urea solution. Next thing we are going to study is the effect of temperature on protein denaturation. For this, what we have done, we have taken a few samples of HSA having a fixed concentration, and we have suspended these samples taken in this Eppin drop, as you can see here in this Eppin drop, suspended in a water bath at different temperatures. The temperature we have taken are 25 degrees centigrade, and that is the room temperature, 37 degrees centigrade the physiological temperature, and the other three temperatures which are adjusted by using water bath were 45 degrees centigrade, 60 degrees centigrade and 80 degrees centigrade. What basically happens is that at higher temperature the protein tends to lose its structure. So, we are going to study how the effect of temperature determines the absorbance of protein. Now, let us see the absorbance at 25 degrees centigrade. So, we have already done the baseline correction, and now we have do the auto zero. In the reference compartment there is only double distilled water. In the sample compartment we have taken HSA solution at 25 degrees centigrade. Now, and one thing let us see out here, that we are monitoring it from 200 to 400 nanometer. Basically what happens is that in the previous case we have monitored up to 600. So, since major peaks are not being observed or observation is restricted up to this region, so it is better not to consider above 400 for the time being. So, let us find out. Here again it is around 278, the value is coming 0.043. Now, we can save it. In the denaturation part we can make a folder having temperature, and here we can save it as HSA as 25, suggesting 25 degrees centigrade. Again save it in the text format. Now, we are going to see its absorbance at around in the same region. We are going to study the absorbance at this region at 37 degrees centigrade. So, now we are going to take the absorbance at 37 degrees centigrade. For this, let us go auto zero once again. And start. Here we can see the protein, the absorbance value is more or less equal to that of 25 degrees centigrade. We will zoom it once this is complete. Here we can see the absorbance value slightly changes, but not that much out here, which signifies that more or less the protein retains its structure at around 37 and 25 degrees centigrade. Now, we will shift to 45 degrees centigrade and see what heat causes to protein structure. So, the auto zero has been done, it is set to 0, and let us start at 45 degrees centigrade. Here is the spectra of a protein at 45 degrees centigrade. We can see the absorbance increases, that is the denaturation has started occurring. Again here we can see its peak around 278. Now one small thing to notice out here is that the sharp peak is not obtained here, because since the protein has started denaturating, the structure basically is not like that of the parent structure. Since the protein has started denaturating, the structure changes, thereby a peak is not observed out here. However, we can assume that there is a peak out here whose intensity is much higher than the normal part. Now we will go to the higher temperature, that is 60 degrees centigrade. Now we are going to see the absorbance of protein for temperature 60 degrees centigrade. Now we can see a proper peak is not observed out here, again the absorbance increases. However, proper peak is not obtained here, rather a shoulder. For that what we need to do, we need to subtract blank. What is the blank? Actually basically it should be, or blank or control, it should be only the solvent in that current condition. So it again increases around 278. The absorbance again increases, as we can see. The last one we are going to do is for 80 degrees centigrade. Now we will be measuring the absorbance value for HSA solution, which is kept at 80 degrees centigrade. Here we can see the absorbance is quite higher as compared to the other two, which signifies that at a very high temperature the structure completely denaturates. So this is for 80 degrees centigrade, this one is for 60, this is around 45, and these two are 25 and 37. So from this part what we can basically see is that for 25 and 37 these are very close to one another, and for a higher part the absorbance increases. So we have seen how temperature affects the structure of protein. Basically what is happening there, when a protein is being heated, its structure gradually breaks, the hydrogen bond breaks at first, and then the entire structure collapses, and that is why denaturation takes place. So hydrogen bonding, we know it's not that much strong like covalent bonding. So upon the heat, upon applying heat, the hydrogen bond breaks, and that's why we can see an increase in absorbance. And why the increase in absorbance? Because the same fundamental principle applies. When protein is denaturated, the structure breaks, it unfolds, the tryptophan residue present within the core of the protein is being exposed within the solution, thereby more and more tryptophan is exposed in the solution, and that is why the absorbance increases. Now, while doing the experiment, one thing we have to note down here, which you should follow, is that in order to obtain a proper peak out here, like the peak, shoulder is coming, no proper peak is coming, but you have to do a control subtraction or a blank subtraction. So what should be that? So after you have done with this experiment, you have to take the solvent, that is your double distilled water, kept in that same condition, and then you have to take the absorbance value. So what does that mean? For example, you are taking a protein solution of around say 100 micromolar protein solution, and you are heating it around 40 to 45 degrees centigrade and taking the absorbance, and the solvent you are using is water or buffer, whatever be the case. Now the control should be exactly buffer or the solvent or anything except the protein. So if you add actually protein plus component A, which giving the solution, then in the control you have to take only the component A without protein. Why? Because if the component A have any sort of contribution in the absorbance, may not be a peak or some sort of other contribution in the absorbance, so it will get nullified. So what you have to do is that after you have taken, save these files as data format, then again take the absorbance value of the control. Now suppose for this case, for 80 degrees centigrade, we have taken the protein, heated it and taken the absorbance value. Now we have to similarly heat that amount of water and again take the absorbance value. logically speaking, we do not think water shall give any absorbance value, but however it is recommended to do it, because the next time you will not stick to what you will get a buffer or in other medium or whatever be the case. So, it is better to take this control subtraction. So, what we have done is that we have taken initially urea solution, taken the absorbance of HSA protein, and so what we have done initially, we have taken HSA solution and we have applied stress in the form of denaturant or temperature, and in both the cases we can see increase in the value of absorbance, and which implies that protein denaturation is taking place. So, one small practical application of protein denaturation which we can basically relate is that why during diseases or why when we get fever, why do we feel weak? So, it might apply that when we get fever, our body temperature arises. Basically, it arises to fight with the bacteria or whatever the infection is, it either viral or virus or something like that. However, in doing so, other proteins present in our body gradually loses its function. Why? Because the structure of the protein might deteriorate when the body temperature arises, and that is why the protein stop functioning, and as protein stop functioning we gradually feel weak, and that is why during fever weakness is one of the reason when protein gradually starts, and that is why during fever that is the reason why we feel weak, because the protein denaturates. Not at all, some protein might denaturate, and as a result we start to feel weak because the protein gradually stops its function, and that is the reason why temperature affects the structure of protein.